Okay, so we're going to start today talking about classifying and ordering real numbers. But before we talk about classifying and ordering them, we're going to talk about what a real number is. So all the numbers that we're worried about in Algebra 1 are going to be real numbers. What do you think the opposite of real numbers are? What do you think the opposite of real numbers are? Go ahead, you can answer. I'm just walking. What do you think? Irrational? No, irrational are actually part of real. I can see why you would say that though, because it does seem a little bit opposite. If I say if somebody's being real, if they're being the opposite of real, what are they being? Fake. Fake? Okay, so fake. So we would call them imaginary. All right, so the opposite of real numbers are imaginary numbers. We're not going to deal with imaginary numbers in Algebra 1, but just as like a little, if you ever see this, like I square root of 8, that's an imaginary number, okay? Luckily, you don't need to worry about it in Algebra 1. We're just going to deal with real numbers. And the 4 types of real numbers that we care about are the ones that are written up here right now. So everything that's on this board is on the slides that you have. But as I write on the board, my suggestion would be whatever I write, you should write it as your notes for the day, okay? So if I were you, I would just take notes right on the slides and then save the slides as your notes. If you would rather take notes in a different notebook, slides are right up here on this desk. If you'd rather take notes in a notebook, that's fine. But make sure you save the slides so you have them, because otherwise you're going to waste your time writing down a lot of stuff that's already written for you, okay? So, again, if I'm writing it on the board, you should probably write it down on the slides as well. They're right there, past the box of markers. Yep. Okay. All right. So we have 4 types of real numbers that we're going to talk about today. We're going to talk about whole numbers, integers, and then rational and irrational numbers. And irrational is what Emily brought up earlier. And it's important, and I'm not surprised that she said that, because irrational numbers are a little bit weird. Okay? So I'm going to go to the next slide. Basically, in our 4 groups of numbers, we have whole numbers, which is the smallest group. Integers includes the whole numbers. Rational numbers includes integers and the whole numbers. And then irrational numbers are kind of off to the side by themselves. All right? So keep that picture in mind as we go through what they are. So what is a whole number? What's a whole number? You don't need to define it. Just you can give me an example. 1. 1 is a whole number. Good. Okay. What else is a whole number? 2. Shout them out. Go ahead. 2, 3, 4, 5, 6, 7, 8, 9, 10, right? All of those numbers are called whole numbers. Why are they called whole numbers? What do they have in common?
They don't have like a fraction.
Yeah, they have no fraction or no decimal after them, right? They're just your whole regular numbers. Does anyone know where they start? What's the smallest whole number?
0.
0. Very good. So would they go from 0, 1, 2, 3, ... What does that ... mean? The list keeps going. Why wouldn't I keep writing my list? How long would I be here?
You won't stop.
For the rest of my life, okay? And I love this school and I love this place, but I don't want to be standing in this room making a list of all the whole numbers for the rest of my life, because they go all the way up to what? Infinity. All the way up to infinity. Does anybody know how to draw infinity? It looks like an 8, but on its side, right? Okay, so it goes all the way up to infinity. So from 0 to infinity. What is infinity? Is it an actual number? No? It's more, it's like a concept, right? What is it? What is the concept of infinity? It will go forever. We can't count that high. In fact, we stopped naming the numbers that go that high because there's nothing that you would need to, like, think about a bank account, for example, right? Now, my bank account, I don't need to go very high at all, right? I only need to, I'm not going to tell you, that would be embarrassing, but it's a pretty small number, right? But Bill Gates needs to go up into the billions, right? So there was a reason to keep naming numbers up into the billions, because people had billions of dollars. And then you get to what comes after billions? Trillions. And then I don't even know, right? You can think of that number. You know what happens as they get bigger. What do you add to the end of numbers? Zeros. You can think about adding all those zeros, right? Do you need a name for it to know that the number is getting bigger and bigger? No, not necessarily. It gets bigger forever, all the way until you get to infinity, which isn't an actual number. It's just a concept that you can keep adding zeros. Okay? So those are all the whole numbers. Now, the whole numbers do not include what?
Negative.
They don't include negatives. What does include negatives? Integers. So integers are all the negatives and all the positives that don't have decimals and fractions. Okay, so they go from negative infinity to positive infinity, but they do not include fractions or decimals. Okay, so it's all the whole numbers and their opposites, basically. So 5 and negative 5, 6 and negative 6, 7 and negative 7. No fractions and decimals. Still no fractions and decimals. So a lot of times the way people describe integers is all the numbers on a number line. The numbers that you see. How many of you guys in elementary school had teachers who put number lines up around the room? Okay, so all the numbers on those number lines are usually called integers. Now, we need a name to include all the fractions and decimals. So here we have, what are these? Rational numbers. Rational numbers are all the whole numbers, all the integers, and all the decimals and fractions in between. Okay? So for example, 1.25, 7.8, 3 1/4, negative 6.333 repeating. These are all the rational numbers. Okay? So they include whole numbers, which means is 5 rational? Yes, it is rational. It's also a whole number and it's also an integer. But rational is just a little bit more specific. So rational is the biggest of these three groups because it's all those numbers. All right? What's happening here with this number, negative 6.333? It's repeating. What does that mean, repeating? It keeps going on forever and ever, but it does so with a pattern, right? You know what's going to come next. Another 3, and after that, another 3. For how long? I'd be here forever too, right? But there is a pattern to it, so it's rational, okay? As long as there's a pattern, even if it goes forever, it's a rational number. So then what the heck is an irrational number?
Non-repeating.
It's non-repeating, which means what? It does have a decimal. It definitely has a decimal, but what's happening with the decimals? Nope, they go forever, but there is no pattern. Exactly, there's no pattern. So one of the most common ones is what? Pi. Very good. So pi is our most common irrational number. All right? Now, how many of you guys used pi previously? When? Circles, yeah, circumference and area, right? So pi, and what number did you use? 3.14 or 159? You had a very specific teacher. Most people use 3.14, but is that actually what pi is? No, because pi goes 3.14159, blah, 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 blah. There are people who have it memorized. I don't. That's as far as I can go, right? But most of the time we say we approximate it to 3.14, which means what? What does approximate mean?
Round it up.
We round it. Why do we round it? Because we're lazy and it's kind of annoying to write all the other numbers out, right? So we round it, but it does go on forever. So it would be something like 2.1735421 going on forever. Do you see a pattern here? No. So it's an irrational number, okay? If it repeats with a pattern, it's rational. If it repeats, or if it does not repeat and there is no pattern, it's irrational. Because what does irrational mean? If someone tells you you're acting irrationally, how are you acting? Odd, kind of strange. Not like you'd expect, right? Not like you would expect someone to behave. So that's why they're called irrational numbers. All right, the other ones that you will see that this will come up is things like this. So what is this? What does that mean? It's a square root symbol. What does square root 25 mean? what it's multiplied by. So what is the square root of 25? 5. Why? 5 times 5 is 25. Very good. So 5 times 5 is 25. So the square root of 25 then is 5. So is that rational or irrational? Rational. It's a perfect square, right? What about square root of 13? Why is that irrational? It's not a perfect square. If you type that into a calculator, what would it give you? Some decimal number that has no pattern and doesn't repeat. So it's actually going to, does anyone have a guess?
4.1.
That's too big.
5.
Way too big.
1.9.
Is it bigger or smaller than this one? Smaller?
2.
Bigger.
Oh.
No, it's too big.
3.5.
3.5 something, right? Probably somewhere in the 3s. Now, the reason that we know that, it's something else. It's bigger, or it's smaller than 25, so it has to be smaller than 5. What's the next perfect square? 25. Ooh,
No.
getting closer.
2.
16. Why is 16 a perfect square?
Because it's going by
4 times 4 gives you 16. Okay, so the square root of 16, is it still bigger or smaller than that? 13 is bigger or smaller than 16? Smaller, so it should be smaller than 4. All right, we're going to do a whole lesson on this later this unit, so don't worry about that too much right now. But this one is irrational because it's not a perfect square, which means is the answer a whole number? No. Okay, so that's why it's irrational. Whereas over here, this one's rational because the square root of 25 is nice, neat 5. Okay? All right, so this picture is just showing everything we just talked about. You basically have two groups of numbers, irrational and rational. And then inside the rational group, what do you have? Integers and whole numbers. And sometimes we talk about natural numbers or counting numbers. We're not going to worry about that in here. But all that means is basically it's all the whole numbers except it does not include 0. But don't worry about that for right now. Okay? So then what we're going to talk about is how to classify those. So what does it mean to classify something? What does it mean to classify something? If I were going through and I were classifying you guys, what would I be doing? Isabel? Go ahead. Yeah, like putting names on things. I heard categories. Means to like give something a name, right? So ways that I could classify you guys. I could say you guys are the class of 2021. Yes, you are the class of 2021. And if I said get into a group of the class of 2021, how many of you guys would be in it? Every one of you, right? If I said get into a group of people who are wearing vests, would everybody be in it? No. So I've classified you in a different way, right? Then everybody wearing a vest would be in one group. Everybody wearing a sweater would be in a different group, right? So classification is putting into groups. So when we classify numbers, we're putting them into groups. And we want to name all the groups that they fit into. So I want to tell if a number is real, if it's rational, or irrational. And then I want to tell if it's a whole number and if it's an integer. Okay, so when you're going through and classifying, those are the ones that you need to look out for. So take a look at -6. Is -6 real?
Yes.
Yes. Remember, all the numbers that we're dealing with in this class are going to be real. So if you don't see an I, a little I, they're all real. So this one is real. What else is it?
Integer.
It's an integer. Is it a whole number? No, why not? Because it's negative. Okay, so it's negative. And if it's not a whole number, then is it rational or irrational? Rational. My only irrational numbers are going to be the ones that do what? Does not have a pattern. So a decimal with no pattern. Good. Okay. What about 75%? I don't know. Well, it's definitely real because it doesn't have an I. But is it even really a number right now?
No, it's the same.
It's a percent. So I need to turn it into a number we're familiar with first. So I want to either turn it into a fraction or a decimal. I think it's probably easier to turn it into a decimal. What decimal is this? 0.75. So now it's still, Reggie's right, it's still real. Okay? Is it rational or irrational? Rational, because it doesn't go on forever. All right. Is it a whole number?
No.
Is it an integer? No, because it's got a decimal. So this one is only real and rational. But what did you have to do first? You had to convert it. All right. In other words, you simplify first. We need something we can recognize. So for number 3, how can you recognize it? Right now, what does it say? Square root of 9, which really means what? 3. Very good. So we simplify that to 3. And now we say, is that real? Yeah. Rational or irrational? Rational. It is also a whole number. And it's an integer. All right, so that's all of those. So when you're doing these problems, you can't just say real for all of them. You got to name everything that it is, all right? So classify it in every category that it goes into. Last but not least, square root of 5. It's real. Why is that one irrational? Yeah. Is it a perfect square? No. So if you did it in a calculator, what kind of number would it give you? Some decimal that has no pattern, that doesn't repeat, that goes on forever. Good. So that's real, irrational. As soon as it's irrational, can it be anything else? No. Nope. So you're done there. Okay, so you guys are going to go do your first practice, but hang on, I want to explain this. So I don't want you to copy this whole chart. It says on here, copy the chart. Don't copy the whole chart. Just do what we just did right here. So make a list of what it is, and I only want you to do 2 and 3 and 5 and 7. So just those, all right? Just those, and make a list of what it is. Real, rational or irrational, whole, integer. At your boards, go. So when we classify them, we put them into groups. What does it mean to order them? Usually just putting them in some type of order from least to greatest, or sometimes greatest to least. I always do least to greatest. If it doesn't tell you, then you can do it either way. Typically on a test, I'll tell you least to greatest or greatest to least, okay? So least means that we're talking about starting with what kind of number, the biggest or the smallest? Smallest. The least means the smallest, and then least to greatest, greatest means the highest, the biggest number, right? So we've got a list here right now of how many numbers? 4. But what do I have to do before I can put them in order? I have to simplify them so that they're all what? Either decimals or fractions. I think it's going to be easier to make them all decimals. Why? There's only one fraction. So all the other ones are already decimals, so you might as well make them all decimals. So in this case, I'm going to change this one to a decimal. How do I do that? How do I change a fraction to a decimal? Divide it? How do I divide that? 100 divided by 5 or 5 divided by 100? 5 divided by 100, which means the 5 goes inside and the 100 goes on the outside. But I'm stuck because 100 doesn't go into 5, so what do I do?
You gotta put a decimal.
I have to put a decimal where?
Like after the 5.
After the 5? It still doesn't go in, so then what?
Zero.
How many zeros?
2.
Why do I need 2?
Because
It still won't fit into 50, right? So I need at least another one. Now, what do I do with this decimal? Move it up. And I say 100 goes into 5 how many times? Into 5?
0.
Into 50?
0.
Into 500. Okay, so now I'm done. 0.05. My other numbers are negative 2.1, 0.5, and negative 0.5. So my first step was to get them all in the same format. So now that they're all decimals, which one of those is my smallest number? Negative 2.1, yes. Why do people often think that this one is the smallest number, negative 0.5? Why might that be a mistake somebody would make? Marina, what do you think?
Because it's smaller than like 2.1, but
Yes.
when it's negative, it's the opposite.
Okay. Can you say that one more time? Because that's really important.
Because people get it wrong
Mhm.
because it's a smaller number, but when it's negative, it's opposite.
Yeah.
So the biggest number is going to be like the least.
Very good. So if these were positive numbers, 0.5 would be smaller, right? But because they're negatives, it's the opposite. So it's the opposite. So then our actual smallest number is negative 2.1. Then what would come next? Now negative 0.5. Okay, what would come next? So we're done with this one, so now we're just looking at these two. Which is bigger? 0.5 is bigger. 0.05 is like having how much money? 5 cents. 0.5 is like having 50 cents. Which would you rather have? I would rather have 50 cents. That's bigger, right? So 0.05 and then 0.5 is my biggest. So this is in order from least to greatest. And again, if I don't tell you, you can either do least to greatest or greatest to least. Typically, I always do least to greatest. Okay, let's try one more. Ignore this. I thought it was like a typo and I forgot to spell check it. All right, so that blue line means nothing. Okay, what do we have here? 0.44. A fraction. So what should I do with that fraction? Divide it. So I'm going to do 3 divided by 8. Be patient with me on this one. It's a little bit long. So what do I do? Add a decimal, add a 0. How many times does 8 go into 30? Sorry, 3, 0. How many times does it go into 30? 3 times. 3 times 8 is? Good. What's 30 minus 24? Okay, but now what do I do? Add another 0. How many zeros can I add? As many as I need to until it stops, right? So now it's 60. How many times does 8 go into 60? 7 times 8 is 60 minus 56? 4. Good, we're almost done. How many times does 8 go into 40? Okay, now we're done. So that was kind of a long one, right? Okay, but we're done because what's 8 times 5? 40. And it gave us 0. So now we're done. That's our decimal. Okay? And then what's the other one we need to change? 2 divided by 5. Add a decimal, add a 0. Bring it up. How many times does 5 go into 20? 20. 4. Very good. Why do I not need to keep going? Because it goes in evenly. So we're done there. So those are my decimals. I'm going to rewrite them. 0.44, 0.375, 0.5, and 0.4. Okay, least to greatest. What's my least number? 0.375. So Alan says 0.375, and he's correct. That's my smallest one. It's weird because it's the longest, so you might think it's the biggest, but how come that's actually the smallest? After the decimal, and what does it start with?
3.
A 3. So you're looking at what place value is that? The tenths, right? The tenths place. I don't talk like that normally, just understand. After the decimal is when you add the th, right? So the tenths place is what we're looking at. So my smallest number is the one with the smallest tenths place, which is 0.375. So then what comes next? Reggie, 0.4, not 0.44. Why?
Because it's like 4 cents, and then 0.44 is like 44 cents.
Good. So this is like 44 cents, and this is like 40 cents, and I'd rather have 44 cents. So then we go 0.44, and then what's my biggest? Which is like how many cents? That's like having 50 cents. Good. So now I'm going in order of least to greatest. I wrote it vertically this time instead. That's fine too. Okay? Remember, when they're decimals, you're looking at the tenths place. If the tenths place isn't enough to tell you, then you look at the hundredths place. Good. How come there's no oneths place? Because then it wouldn't be a decimal, right? That'd be a whole number. All right. Okay. Sometimes it can be helpful. Some people think this is helpful. If you do not worry about it. You don't have to do it. But some people think it's helpful to place things on a number line. Who might think that's helpful? Not like raise your hand, but like why might you think that's helpful?
So you won't get messed up?
Yeah, you don't get messed up, right? It's very visual. So people who are visual learners that like to look at things and see things, this might really help you. So I'm going to take these numbers and I'm going to put them on a number line. Where is -5? Well, that's right here. So -5. 2 is where? After the 0 right here. So this is a 2. All right. And then -5.5. Where is that? I go here and I keep going backwards. So it's right here, -5.5. And then 3 is over here. So now if I'm going in order from least to greatest, what's my smallest? Then what? Perfect. Okay? If that's helpful to you, by all means, draw a number line. Okay? If that's not helpful to you and you could have done that without the number line, then don't ever feel like you have to use it. I want you to give you tools that are helpful to you. I don't want to waste your time. Okay? So I'm not ever going to be like, and you must put it on a number line. I'm just going to say, if it helps you, put it on a number line. All right? Some people that's very helpful. Some people it doesn't, they don't need it. Okay. All right, so at your boards, I would like you to do 2 and 4. 2 and 4. This one's really tiny. This says 2 squared.